After going over Gauss elimination in a completely handwritten method, in an assisted MATLAB, row by row, I think that was actually Gauss-Jordan method there, but now it's finally time to look at a script form. This is a script provided by the textbook authors that handles Gauss elimination as well as pivot operations. So it will automatically switch rows around to help prevent zeros from causing an issue. So just with most functions, you feed it matrices A and B, which we still have programmed in from the Gauss-Jordan elimination. So we should just say go, whoops, am I not in the right? Yeah, change folder. Okay. Not enough input arguments, that's fine. We'll go up here to the actual input argument one again, and it's done. 2, 3, 1, and -2. Those are the solutions if you remember them. If only everything in life was that simple and required no explanation, but the point of the class is to teach you what's going on. So we've shown that it works. Now why in the world does it work? They went in and first joined matrices A and B, essentially the same as horizontal concatenation, saved the size into variables R and C for row and column, and then the pivoting section, the whole code that handles switching rows around. Just keep in mind there's nothing sacred or nothing set in stone about which equation is first, which equation is fourth. The only reason that you have one equation on top, one in the middle, and one on the bottom is because that's the way you happen to write them down. You can shift them around as much as you care to. So if you find a 0 in a position, that's completely undermining the performance of your Gauss elimination function or Gauss-Jordan function. Just move the equations around. If you find that you have a set of equations that if you just change their order is already in upper triangular, or even better, is already in purely diagonal form, don't do any row operations. Just rewrite the equations in a different order, solve the problem, and you're done. That might make a good test scenario. That'd be interesting. So, in the pivoting section, they start cycling through all the different rows, seeking out which one has the largest pivot element. Now keep in mind, that is the element in the column of interest. So as you're seeking to create zeros in the leftmost column, that will be probably the first row. And then as you move down one, you actually start pivoting the second, then you pivot the third, then the fourth and the fifth, till you reach the magnitude of the matrix you're operating on, and you've completed the upper triangular form. So at first they just look for it. They identify which row has the largest pivot element. Again, that they have to call it pivot element and not the largest first element, because you're not always looking at the first column for the pivot. Sometimes you want the first column or the second column or the third or all three of those to be zeros, so you don't mess up the work you've already accomplished by setting so many other entries to 0. So if you find a row with a larger pivot element, and that row is not the one you're already using in the right place, then move it. Those are the 2 steps. Identify the largest pivot row, and if that row is not already in the right spot, then put it there. Swap it with the other. They say, if you notice, they save it to a temporary variable, copy the other one over, and then swap the temporary variable back in. So they kind of they remember, put in memory what used to be there, override it, and then copy back from memory in the old spot. So just swapping 2 rows in position. Pretty straightforward. So all of this up here, all of that mass is just kind of extraneous to the actual Gauss solution. What's neat is that the entirety of Gauss is handled there. Once you're done with Gauss, you solve the upper triangular variable calculation. So that's just doing a loop, going through all the different rows, starting with the one solution that's obvious at the bottom, usually for Gauss elimination. And then you sequentially take that extra information that you've solved till you have knowledge of every one of the unknown x's, and you're finished. So it's actually very impressive that the entirety of Gauss elimination can be handled with basically 3 operations. Let's see here, those zeros are not terribly functional. So that loop right there is everything. So that is a code you can use for Gauss pivot large. It's called Gauss pivot large, but you can use it for Gauss elimination, incorporating automatically pivoting data that could otherwise cause a problem. This is again offered by your textbook's authors, and well, I'll just leave this paused on the screen because you're going to pause the video anyway and probably just copy this in, so might as well make it easy. Hope that helps. Definitely study the row operations, how they've set up that operation. It's very concise, actually quite elegant. So if you can understand how that's done in MATLAB, you're a long way to programming advanced functions.